So one of our new formulas is that sine 2 theta is equal to 2 sine theta cos theta. And I'm going to prove it for you guys. And the neat thing about this proof is, like some years I've said, okay, try something on your own. And students work for like 3 or 4 minutes and get nowhere. So we'll just imagine we work for 4 minutes and are still stuck. Some of you are like, yeah, that's not hard to imagine. Okay? And then I give a hint. And the hint for this proof is to use mathematics that you learned in the past. But you're going to have to go way back. You're going to have to go way back. The key to doing this proof is using mathematics you learned probably in kindergarten. What are like some of the things you learned in kindergarten? Can't even think back, right? Do you even remember your kindergarten teacher's name? Okay, that's good. No? You skipped kindergarten. You're advanced. What are some things you learned in kindergarten? Very basic math. To count? Good. What else do you think you learned in kindergarten? Addition. So do you think you could have done 1 plus 1 equals 2? And that's actually the key to this proof. You see this 2, and we write it as 1 theta plus 1 theta equals 2. Which seems like so easy and counterintuitive that you would think not to write it down. But if we do that, I have my alpha plus beta formula, which we already have learned. And that would give me sine alpha cos beta plus cos alpha sine beta. But both the alpha and the beta are both thetas. Can you see that those are like terms? Sine theta cos theta plus another sine theta cos theta, which would give me, again, using the brilliance you learned in kindergarten, 2 of them. 2 sine theta cos theta. And our proof is done. So on the formulas on the page, top of page 654, which are listed there, notice there's 1 for sine. They give you 1 for tangent, but they give you 1, 2, 3 different ones for cos. And you could very easily prove the cos 2 theta one with this same technique. If you go cos theta plus theta, you could go to your cos formula, and it would be cos theta minus sine theta. You would very easily get this first one, cos squared theta minus sine squared theta. At the bottom of page 653, they show you why there's 2 other ones. First of all, if I have a sine squared theta, do you see with your identities, you could change that to 1 minus cos squared theta, because sine squared theta plus cos squared theta equals 1. And if you did that and simplified, you would just get cos instead of cos and sine. Similarly, this is all at the bottom of page 653. If you replace the cos squared theta with 1 minus sine squared theta, you would get an equation with only sine squared. So sometimes we're going to get a cos 2 theta in a question, and it'd be like, oh, it would sure be nice if we changed it only to cosine. Well, you could. Or it sure would be nice if you changed it only to sine. Well, you could. So that's why they've listed all 3. But really, if you have the 1, you can see the other 2 are easy to find just with a simple substitution. All right, so this time we'll go in order. Now, if I start reading this question, given an angle theta is in standard position with the terminal arm in quadrant 4 and cos theta equals 2/5, we've actually, I'm going to underline this in yellow, we've actually had a ton of questions start this way, even in chapter 6. And I hope you're getting really good at saying, hey, I can draw a triangle, because this is a trigonometry unit, I can draw a triangle to help me with that. Then, once I have that triangle, maybe it's going to help me with these things. So in A, well, if I know it's in quadrant 4, and I go back to my nearest x-axis so that I have a reference angle. Again, when drawing a triangle, we always go back to the nearest x-axis so that it includes our reference angle. And cos is adjacent over hypotenuse. You could do a squared plus b squared equals c squared. Hopefully you're getting really good at that in your head. And get the square root of 21 for the other side. Once I have this, do you see that you not only have cos of theta is 2/5, you would also have sine of theta to be negative root 21 over 5. And we want to find sine of 2 theta. Well, in order to find sine of 2 theta, these are thetas. You are not allowed to just multiply this by 2, because it's inside the sine. You can multiply the outside by 2, but not the inside. The only thing you would be allowed to do with a 2 theta on the inside is go to your formula sheet and say, according to my identities, this is true. And if that's true, well, I already know from my triangle that sine of theta is negative root 21 over 5. And I already know from the question and from the triangle that cos of theta was positive 2/5. If I multiply everything together, remember this 2 out in front is 2 over 1. How do we multiply fractions? Multiply the tops. And multiply the bottoms. So in part B, we want to find cos 2 theta. And in part B, you would have a choice of any one of those 3 formulas. But I'll always say, technically one is always like just a little bit better than the other ones. You could use any one of the 3 formulas and you could get the answer right. In this question in particular, I'm going to tell you that this one is the best. Why do you think that one's the best? Any guesses why I would say in this case this one's the best? They're all going to get you the right answer. What's different than this one than the other one? The other one, there's one that has only sine, and there's one that has cos and sine. There's only one of them, so there is a 1, but there would be a 1 in the 1 minus sine squared 1, too. Yeah, look at the question. They gave us cos. You still have a possibility of getting it wrong, and trust me, some people do. It's sometimes very hard to just look at the number and write the same thing down again. But you have a better chance of making a mistake getting sine, because you actually solved for it. So we might have, but we didn't. You're worried. We got sine theta right. But we could have made a mistake. Maybe we forgot a negative sign or something. So using this, we're guaranteed, unless we write it down wrong, to at least plug in the number right. Now you have to do order of operations. Do you see that squaring would happen first? That'll be 4 over 25 minus 1. And 2 times 4 is 8 over 25 Minus 1, I'd have to get a common denominator. And we get negative 17 over 25. I'm going to add a part C. Using your answers from A and B, how does that help you find the answer to this question? In what quadrant is 2 theta? Quadrant 1, quadrant 2, quadrant 3, or quadrant 4? Theta was in quadrant 4. But what quadrant will 2 theta be in? Well, what did we find out in A? We found out in A that sine of 2 theta was negative 4 root 21 over 25. Can you see the fact that sine was negative? You know that 2 theta from A could be in quadrant 3 or quadrant 4, according to your CAS rule. Then in B, we found out that cos of theta was also negative. According to your CAS rule, it's 2 or 3, but the only one that has both of those would be quadrant 3. Okay, questions you can circle for this? Number 9.